Hello, this is next video on greedy algorithms. Here is the question, read it and give it a try. Bangalore traffic is terrible these days, so to solve this problem, traffic police came up with a problem for which they need your help. Given a parking stand of length n and list of car with horizontal length, you need to tell minimum number of cars which can be added so that sum of cars length form all length from 1 to n. And m is up to 1 and n is up to 2 power 30 and the car length is up to 1 For example, if the length of cars is 3, there are 3 cars and the maximum value of length we have to make is 10 and the values are 1 to 5. There is a car with 1, there is a car with 2, and if we try to take these two, we can get length 3, and we do not have car length 4, so we can add 4, and for 5 we have direct 5, and for 6 we can take 1 and 5, and for 7 we can make 2 and 5, and so on, till we can make all lengths till 10. So the answer is 1 because by adding a simply car of 1 length 4, we can make all from 1 to 10. So the answer is 1. So we can make 1, 2, 3 if we add 4 and there is directly a 5, 6, 7, 8, 9, 10. So the answer is 1 and we have to return simply 1. So for making length x, we want some length from 1 to x minus 1 as we can't make length from x plus 1 and so on. For example, if we want length 3 and the starting li of the element is 4 and if the least element is 4, can we make 3 from this? No, because obviously we can make 3 from some of those before, for example 1 and 2. So for making length x, we must surely have some values in the range 1 to x minus 1. So we want to add 1 for sure if 1 is not in the vector. So for example, if the least element of the vector is 2, and surely we have to make all lengths from 1 to x. So there is no value x, so we must add 1 because 1 can be only made by only a single one. It cannot be added by any other two values because all are greater than 1. So if 1 is already in the vector, no need to add 1. And if there is no 1 in the vector, we have to add 1. So we can observe that we want least elements in the beginning because to make 1, we have to check whether there are possible values of 1 before. Similarly, for example, we are making a length 4 and we have to check whether there is some combination of 1 and 3 or 2 and 2 and so on. Because for value x, we want to check for the values less than x. So surely we have to sort the array so that we can get the least values in of 1 if we are trying to get it. And now let's take some example. If there is only one car and its length 10 and we have to make some n which is very large. So obviously is there one here? No, because we sorted and there is only single element, so the final sorted array is also 10. And is there one? No, so we have to add 1 because we have to make all lengths from 1 to 10, 1 to some very large number. So we have added 1. So the new array is 1 and 10. So is there a 2? No, so we have to add 2 as well. So after adding 2, the elements are 1 to 10. Is there a 3? No, but we can form 3 by 1 plus 2 because we have added 1 and we have added 2 as well. So we can simply make 3 from adding these 2. So no need to add 3 because we have 3 directly itself. So do we have a 4? No. So add a 4. So new vector will be 1, 2, 4 and 10. Can we make 5? Yes, because 1 plus 4 is 5. Can we make 6? 2 plus 4. Can we make 7? It is 1 plus 2 plus 4. So can we make 8? No. So again add 8 and so on. So if we observe something, if we observe one thing, if we are adding some values, some other values are also going added. Because for example, here we are adding only 1 and 2. 3 is automatically formed. And if we are adding 4, 5, 6, 7 are already formed. But why is this? Is this some coincidence or is there any max behind it? So the simplest one is 1 and we are able to make only 1 out of it. And coming to 1 and 2, 1 is the old set and we are adding 2. So we can add, 1 is the element from before vector and 2 we are taking single and we are adding 2 to the every before possible set because we are getting a new value. So obviously we can pair all the elements with this and we can make a new element. So it is 3. And now the new vector is 1 to 3 because we have answers for 1 to 2. And now let's assume that the element 3 is added with this. So 1, 2, 3 are already in the before, so 1, 2, 3 are already here and we are getting new element 3. So we can add 1 to 3, so it is 4. We can add 2 to 3, 5, 3 to 3 is 6. And now we are getting 1, 2, 3, 4. So simply we can form all elements 1 to 10 because 1 to 6 are already here and we can make 7 by adding 4 with 3, 4 with 4, 4 to 5, 4 to 6. So we can get 1 to 10. So for 1 to x, we are able to get all values from 1 to x. 1 to x into x plus 1 by 2. Because for 1 to 4, we are able to get all. Because the least value is 1 and the highest value is sum of all elements, which will be 1 plus 2 plus 3 plus and so on till x. which is x into x plus 1 by 2. So for 1 to x, we were able to get all elements from 1 to x into x plus 1 by 2. So from this example, from before example, we got that we have to track the next value that we are searching for, because we are able to make up to this, and now we want that we are searching for number 4. Else how can we make sure that we are going to search a number? So surely we have to keep a track of number where that is the next number that we are searching for, and all the numbers till that before from 1 are existing in the array, whether that can be in the original array itself or that is forming from elements that we are adding from. So we want to track the next value that you are searching. So let's take again the example, initial example, and let's try to observe how these are changing. So initially the value is 10, and the first number that we are searching is for 1 1, because it's the least value that we are searching for initially. So is there one? No. So we are adding one. So adding here, it means we not directly add to the vector because it's blindly off an operation. So we can just assume that we are adding, and we can make some changes and make that changes in the code. So we are adding 1 in the hypothetical vector. So we got 1, and the next value we are searching for is 2 because there is no 2, and there are no occurrences of 2 ones to make 2. So the next value is 2, and now we have added 2 as well. So the new hypothetical vector is 1 2, and the array is still 10, the original array that we are given. So now is 1 3? No, because 1 plus 2 is equal to 3, and the next number we are searching for is 4. So 1 is equal to 4 because we already got 3 from 1 plus 2, and now we are adding 4 as well. So after adding 4, we discussed that we can get 5 6 7 because 4 plus 1 4 plus 2, and sum of all is 5 6 7. So the next number we want is 8. So we will add 8 as well, and 1 to 4 8 and 10. So 1 is equal to 16. So let's keep this aside, and if we observe, if we have values 1 2, we discussed that we can make all elements from 1 to x into x plus 1 by 2. So for 1 to 2 we can make 1 to 3, for 1 to 4 we can make 1 to 7, and 1 to 8 we can make 1 to 15. So now this is the new hypothetical vector, and this is 10. So we want 16. So do we really have to add 16? Because here we have added 4 because we cannot make 4. So here we have added 10 because we have added 8 because we cannot make 8 from the given vector. So can we make 16 from this, or do we have 16? So let's keep this aside, and let's take the simple code, because want is 8 till now, and we are adding directly the vectors with want. But here it is not the case. So let's first take the first part. So how want is changing, how the want variable is changing. So let's assume that the hypothetical vector is 1 2, and the number we are searching for is 4. So why want is equal to 4? Why it is not 3? Because maximum value we can make with 1 2, because we have added this so far. So what is the maximum value that we can make out of this? It is want minus 1, because it is 1 to 1 plus 2. So it is 1 plus 2 and it is 3. So the maximum value where we are able to make is want minus 1. So the next value we are searching is want, because we have made all elements from 1 to want minus 1. So what is the next element? It is simply want minus 1 plus 1, which is want. So we are directly adding want value, which is 1 to 4. So we have made this, and what will be the new want value? So let's assume that 1 2, and the values that we can make from 1 to are 1 and so on till want minus 1, because want is equal to 4, and the maximum value we can make from 1 to is 3. So from 1 to, the maximum values we can make are 1 till want minus 1. So now the next want value is want, because we are searching for 4. So let's add that in the vector. So 1 2 is the old one, and we are adding 1 because we want this one, and we were not able to make this from previous element. So we are adding 1 to the new vector. And now what is the maximum value that we can search for? It will be simply maximum of sum of all these values. So it is 1 plus 2 plus and so on till want. And we got that sum of 1 to 2 is want minus 1. Why? Because want is equal to 4 we are searching, and the sum of all values is want minus 1. So sum of all values till before want is want minus 1, and we have added want. So what is the total sum? It will be want plus want minus 1. So we got this. So we got all values from 1 to this value. So now what is the next value we are searching for? It is simply this plus 1. So it is 2 into want. So we got that. We assumed that we got a simple example, and we are searching for 4. So why we are searching for 4? Because we were able to make all elements from 1 to 3. So we were able to make this. So now we are adding 4, and now we searched for what is the new value. And what is the new value? This is want, and from before set we were able to make all elements from 1 to want minus 1. So the maximum value of that we can make is want minus 1 in the before set, and we are adding want. So what is the maximum, what is the total sum now? It is 2 into want minus 1. So the new value that we did not have currently and we are searching for is 2 into want. So simply, initially it is 1. So next it is 2, next it is 4, and it is 8, and it here is 16. So now let's check this case. So now let's come to this, and want is equal to 16, as we have discussed, it is becoming twice the before value. So is want really 16 here? No, because we have 10, and we got that we can make all values from 1 to 15 here. So we can make 6 as well because it lies in the range. So we can make 10 plus 6 as well. So 1 to 15 is the set of all values that we can make from 1 to 48. So we got new element 10. So what are the new values that can be found? So we can pair 10 with 1, so it is 11. We can pair 10 with 2, it is 12. And we can make 10 with 15, so it is 25. So are you able to observe one thing? We are able to make all the elements from 1 to 25 because up to 15 all elements are here, and all values from 16 to 25 are here. So the new value we are searching for is 26, and it is not 16. Why is this? So why not? Why want is not twice here as in the before cases? Because we were able to make all elements from 1 to 15 here, and v of j. So the first value that we are still at is 10, and that is less than or equal to 1 because it is 16 here and it is 10. V of j is 10 because we are at the first index, and want is 16. So the maximum value that we can make is want minus 1 from this, and this is v of j because we were able to see that we are able to make all elements from 26. So what is 26? It is simply v of j plus want. So it is simply want is equal to want plus v of j. And now why is the case but not before? So let's observe one thing. Because in this one, 1 to 2, all elements that we are able to make out of before are 1 to 3. 1 to 3. And for 1 to 4, 1 to 7. And here it is 1 to 15. So here the value 10 is greater than 10, greater than 3. And here the value is greater than 7. And here the value 10 is less than 15. So it means that even if we are trying to add these, it is 15 here. So let's assume that here the values are 1 to 7 for 1 to 4 this case, and we are adding 10. So if we try to add directly these, what is the next value that we are going to make? 11, because the least value is 1 and the highest value is 7, and we are adding that with 10 because 10 is the new number and we are adding 10 to all numbers possible. So the least value is 11 and the highest value is 17. But we are missing out the middle values because we were not able to make 8, 9, 10 with the before with all values. But here we are able to make 1 to 15. And now even if we are adding 10, we are able to make all elements. Why? Because this value is larger than this, so we are not missing out any values. But here the values are 1 to 7 and the next value is 10. So we must add some values in the middle to get values 8 and 9. But here it is not the case because here we are having numbers 1 to 15 and we are having 10. So it means that we have already made all values till this, and we can simply make add this and we can get a bigger number. So there is no need to add any values before in the middle, but here we have to add because to make 8 and 9. So hope you understand this. So simply want is equal to 1 because it is the initial value that we are searching for. Answer is equal to 0, index is equal to 0. And while want is less than or equal to n because we want all values till n. So the loop will break in when we were able to make all values till n. So if index is less than size and v of index less than or equal to want, it means that this is second case. So if second case want is equal to want plus v of j, because we discussed here that new want is equal to plus equal to v of j. So and we are incrementing index because it is sorted and we have done with 10. Because why we are incrementing it? Because we have utilized 10 to make all the maximum values. So after this we got some value 1 and x, and according to the next value again the same algorithm will be traversed because again we will check whether this value is less than this, and yes we will directly add want value, and else we will add with v of j. So simply if that is less than or equal to 1, it means it is the last case. So it is 1 to 15 and the value is 10, so we can simply add want plus is equal to v of j and we are incrementing it. And if it is not the case, it means we are dealing with the first. So want is equal to want into 2 and we are incrementing answer, because only in this case we are going to add the value with want in the given vector, in the hypothetical vector. So here want is 2 and we are adding 2 in the vector because we are going to add it and hence answer is increasing. But in this case, no need to increment the answer because we are just increasing the range by using the given value. We are not adding. But here we are adding the want value in the new vector. So here is answer plus plus and here there is no answer plus. And finally we are writing the answer. So in this way, if we try to take some examples and some examples, we can simply understand that we are checking for some next value that we are going to check for, and based on those we can get answer. So here is the exact code. So if you have any doubts, comment below. See you in the next video.